Hello again. In the previous lesson, we introduced rational functions, domain restrictions, vertical asymptotes, horizontal asymptotes, holes. So let's begin with the quick rules. Remember, these things are very important, so you can pause the video to read them to you. Let's begin with example number one. So we have this function here, and we need to state these things. So this is a transformation of the parent reciprocal function. Okay, so the parent function is y equals 1 over x. That is a parent. Okay, so the expression x minus 2 shifts the graph to the right x unit. The plus 3 shifts the graph up 3 units. So the transformation is right 2 up 3. For the vertical asymptote, would set the denominator 0. Set the denominator here, 2, 0. So this is the vertical. Right? Right? For the horizontal asymptote, we would use the vertical shift. So the parent graph has a horizontal asymptote, y equals, after the shift, or excuse me, after shifting up 3, the horizontal asymptote becomes y is equal. Okay? So the domain excludes x equals 2. So we have a domain of positive infinity. The range excludes the y equals 3. So the range 3, 3, positive. Now choose points on both sides of x. Okay, there's at least 4 points. Uh, let's do this. Let's choose f of 1. So if we substitute 1 in there, we would end up with, let's see, -1, -1, -1 plus 3. That would give us 2. So that point would 1, 2. If we chose 3, then we would have, let's see, 3 minus, that would be 4. That be 3 comma 4. If we chose 0, 0 minus, let's see, we have 5 halves. That'd be 0, 5 over 2. And if we chose 4, 7 halves, or 0 comma 7 over 2. Okay, so essentially what we can do is plot the plot the asymptotes first, which are these two, then plot the points and see that the graph has two branches, one on each side of x equals 2. You can also put that into Desmos to see what that equation. All right, example number 2, graph using features. Um, so we have g of x equals x plus 1 parentheses divided by parentheses x minus 3. We're going to find these things. So first of all, we need to start with the vertical asymptote because the denominator cannot be equal to 0. We have x minus 3 cannot be equal to 0. Add 3. X cannot equal positive 3. Now we need to find the horizontal asymptote. So the numerator and the denominator both have a degree of 1, as you can see. 1, 1. So the horizontal asymptote is y is equal to 1. Now we need to find the x-intercept. As a matter of fact, let's back up real quick. So the vertical asymptote is x equals 3. So again, by finding the denominator of here, we can find what the vertical asymptote would be 3. The horizontal asymptote would be 1 due to um, the divisor of the ratio of the powers that both have. Okay, and then when we find the x-intercept, we set the numerator equal to 0. So we have, again, x plus 1, 0. Give us x equals -1. Give us a negative 0 intercept. Okay. And then as far as the y-intercept goes, substitute 0. Going to give us 0 plus 1 is 3. Give 0. Give us negative 1/3, or 0 1/3 would be y-intercept. Now let's choose some sample points on both sides of the vertical asymptote of x equals 3. So what we would do is let's choose g of 1. Substitute 1 into the equation here. That would give us 2 divided by negative, which is going to give us -1. Okay, so that point would be 1, -1. Then if we used 2, be 2 plus 1, be 3. 3 over -1 would be -3. So that would be 2, -3. If we used, let's see, now let's use 4 and 5 on the right hand side. So we'll use 4 because we can't use 3, right? We'll use 4. So 4 be 4 plus 1, 4 minus 3, which would be 5. That would be 4, 5. And g of 5, which would be 5 plus 1, 5 minus 3, or 6 divided by 2, which is 3. So that's going to be 5, comma. Okay, so those are all our points. And again, we can sketch the branches. First thing you want to do is use the asymptotes first and the points. The graph essentially approaches x equals 3, but never crosses that vertical line. Okay. All right. Try the pause and try problem. So here you see this has a denominator of x plus 1. So since it has a denominator of x plus 1, we need to set it equal to 0. We have x plus 1 equal to 0. X is going to equal to -1. That is our vertical asymptote. Okay. So we got our vertical asymptote, and then we see that the graph shifts down 4. So what does that mean? That means the horizontal asymptote is y is equal to -4. Okay. So we have the horizontal asymptote of -4. And that means also that the domain excludes this -1 here. So the domain would -infinity, -1, union, -1, comma, positive infinity. Okay. So the range has this exclusion. So the range would be negative infinity, comma, negative 4, union, negative 4, comma, positive infinity. Okay. Now choose 2 points on the left of -1 and to the right of -1. So let's just use -3 and -2, okay, because we don't have much space. So if we did -3, that'd be 2 divided by -3 plus 1 minus 4. -3 plus 1 is going to give us -2. -2 minus 4 is going to give us, let me see, excuse me, 2 divided by -1 minus 4 is going to be -1 minus, going to give us -5. So that's -3, -5. Then we're going to also use -2. So again, that's 2 divided by -2 plus 1. So that's going to result in -6. Okay. Now choose 2 points on the right of -1. So let's use x equals 0 and x equals 1. Okay. So if we, let's see, these will be pretty easy. So that'll be -2. Then we also are going to use 1. So that's going to be -3. So that point is 0, -2, and 1, -3. Okay. And then we can plot the asymptotes and then plot these points and then sketch the two branches. Again, you can put this into Desmos to see what it looks like as well. All right. Example number 3. So we have the expression for the function r of x, and we're asked to identify these things. So we want to start by identifying common factors. We see x minus 1 being a common factor. It appears in the numerator and the denominator. So it cancels, but it still creates a whole. Okay. So we got to understand that. So r of x originally is x minus 1, x plus 2. We have x minus 1 and x minus 3. Okay. Again, this can simplify because this is essentially 1. That's going to be x plus 2, x minus 3, right? So since we know this, we need to understand that there are some restrictions. Okay, those restrictions are x cannot be equal to 1, and x cannot be equal to 3. Okay, so again, this is based on the original function. Okay, we have to take the restrictions of this, set both of these equal to 0, and find the restriction. Now, the canceled factor tells us the wholes. So to find the y value of the whole, we're going to substitute x equals 1 into the simplified functions. We have 1 divided by minus, going to give us -3/2. So the whole, 1, -3. Now, the uncanceled denominator factor gives the vertical asymptote. Okay, so we have x minus 3, 0, which is going to be x to positive 3. Our vertical asymptote is x equals 3. Now, the degree of the simplified numerator and denominator, see, denominator are equal. The leading coefficients are both 0, which means we have a horizontal asymptote of y equals 1. Now, let's find the x-intercept. So the x-intercept, x plus 2 equals 0. which is x equals -2, or -2, 0, right? Okay, according to this. Then the y-intercept. So the y-intercept would be r parentheses 0 equals 0 plus 2, 0 minus 3, r parentheses 0, going to be -thirds. Okay, so that would be 0, -2/3. That would give us our y-intercept. Now choose some key points. Okay, um, we're going to use 1 point on each side of the vertical asymptote. So the vertical asymptote x is equal to 3. So let's use 2 and 4. Okay, so let's use that's going to be +2 minus -4. So that point is 4. Then let's use 4, 4 minus 4, 6. So that point is 4, 6. Now, when graphing, just remember to show the hole at 1, -3, 2. Don't fill that point, right? Let's continue. Example number 4. Compare transformations. So we're going to describe these transformations. First of all, we need to identify something. This is a parent function. So we have f of x equals 1 over x. That is a parent function. Now we're going to compare that with g of x, which is -2 divided by x plus 4 plus 1. Notice the parent function, okay? So the x plus 4 is the denominator, right? And then this is the shift in, excuse me, the shift in x, right? We shift to the left 4 units. And then this shows us that we're going to go up, all right? So the x plus 4 is inside the denominator. That shifts the graph left 4 units, okay? So again, x plus 4 left 4 units. The coefficient of -2 here, right, is essentially outside the reciprocal expression, okay? Just to kind of think about it, it would look like -2 parentheses 1 x plus 4. That's essentially how it looks. So that -2 reflects across the x-axis, the vertical stretch of 2. Okay. Moreover, this +1 means that the graph just shifts up 1 unit. Now, state the asymptotes. So the parent vertical asymptote is the parent vertical asymptote x equals 0, and it shifts to the left 4 units, right? So the vertical asymptote, this our problem is going to be x is equal to -4. So the parent horizontal as excuse me, the parent horizontal asymptote is y is equal to 0. It shifts up 1. Okay. That shift up 1 is going to give us a horizontal asymptote of y is equal to 1. Okay. So the shift left is going to give us a -4, a vertical asymptote of -4. And the shift up 1 is going to give us a horizontal asymptote of 1. So the transformations are left 4 a vertical stretch by 2, and a reflection across the x-axis. Then we're going to go up 1. Let's look at common mistake. So a student connects the 2 branches across a vertical asymptote. Explain why this is incorrect. So a vertical asymptote represents a value of x that the function cannot use. So the graph may approach the vertical asymptote, but it cannot pass through it. Okay, so vertical asymptote equals the excluded x value. So the graph approaches it but does not cross. So the graph approaches but not crosses. So the 2 branches should stay separated. Connecting them would show outputs for an x that is not in the domain, right? All right, here are what we looked at, the quick rules for this lesson. And make sure you watch this if it wasn't clear the first time. Ask question comment section if you need clarification. All right, thank you again for watching.